Now, let me give you further examples on how you can differentiate using first principle. Then from there, I digress to product rule. Okay, second example. Differentiate. Differentiate y equals to 1 over x using first principle. That is to say, FP, first principle. FP, using first principle. Okay? So I have solution. I have y is equals to 1 over x. For this concept, I told us that for every y, there is corresponding change in y. For every x, there is change in x. So with this, I have y plus change in y is equals to 1 over x. So for every x, there is change in x plus change in x. So once you've done something like this, you are good to go. So from here, I'm going to transfer my y to the right hand side of the equation, leaving my change in y. So I have my change in y is equals to 1 over x plus change in x. So this y coming to the right hand side of the equation, the equality sign here alters the sign of this y. Y here is positive, so the equality sign changes it to negative because minus y. So from here, I have changed the y, giving me 1 over x plus change in x minus y. What is my y? Initially, we said that y is equal to 1 over x. So I have 1 over x. Now, change in y is equal to, I'm going to take the LCM of this fraction. So the LCM of the denominators is actually the product. X times this, product of x and x plus change in y. Change in x, sorry. So I have x into x plus change in x. That is my LCM. So this first denominator go into this. This one we cancel out this, leaving you with x. So you have x times 1, which is x, put your minus. This denominator divide this LCM. X will cancel itself as x will cancel x, leaving us with this. So it becomes the whole of this times this one. We have 1 times this will give us x plus 2x. Half. Okay. So by virtue of this, we have change in y is equals to x. X minus, that is to say, minus times x gives us minus x. Minus times this. The minus is having effect on everything inside this bracket. Minus times x gives us minus x. Minus times change in x gives us minus change in x. All over x into x plus change in x. So with this, my change in y automatically becomes s minus s is 0. So we are left with minus change in x. Minus change in x. All over x into bracket x minus change in x. Close the brackets. So this is what we're going to get. So at this point, we divide through by changing x. So we divide everything by changing x. For me to divide changing y by changing x is same thing as saying changing y over changing x. Or another way to this is to say change in y times 1 over changing x. Yes, we are speaking same language. Change in y over change in x is same thing as change in y times 1 over x. So that is the concept I will use here for easy division, easier division, or whatever. Easy division. Uh, so from here, I'll have change in y as 1 over change in x is equals to minus change in s over s is minus s plus change in x times 1 over change in x. So, change in y times 1 over change in x gives us change in y over change in x is equal to, you can see change in x is up, the numerator. Change in x is also down, the denominator. So it will cancel itself. This one will cancel this one, will make it 1. So at the end of the day, we have minus 1 times 1 will give us minus 1 all over this. We have x into bracket x plus change in x. So at this point, we take our limit, taking limit. At this point, we take limit. So taking limit, once you have divided by changing x, the next step is to take limit, the limit of the function. So we take limit. Taking limit, we say change in y over change in x tends to the y in x. We must know this. And so change in y on its own tends to 0. Change in x also tends to 0. So if this principle or concept holds, if it was hold, it then means or it implies that our change in y over change in x has become the y in x. So at this point, we now have that this is change in y over change in x, which has become y in x is equals to minus 1 all over x into bracket x plus change in x. I will say change in x as tends to 0 becomes plus 0. So at the end of the day, we have the y, the x is equal to minus 1 over x times x, which is x squared. That is our answer. Just like I told us, for us to be sure and certain of your answer, whenever you are given this question to solve or to simplify using first principle, first get your answer in general formula method, using general formula method. So if I were to solve this using the general formula method, it's very easy and I could have gotten the answer long time ago. Let me still show you like a rough walk. If I were to do this using general formula, y is equals to 1 over x. If I were to use general formula, of course, I will first transpose this using my knowledge of indices. So by knowledge of indices, this whole thing here is same thing as x raised to power minus 1. So if that is that, I'll have y is equals to x raised to minus 1. Is the concept of indices. And that is why I do tell my students, for you to actually do well in calculus, you must be a boss in indices. You must be very sound in indices. So your knowledge of indices helps you scale through calculus. It will help you do well in the concept of calculus. So we have y is equals to x raised to power minus 1. For my general formula, of course, we know that I'm going to differentiate the y with respect to x. So by virtue of that, I have the y, the x is equals to, what did I say before? You first bring down your power. What is the power? Minus 1. Use it to multiply everything you have and constant x raised to minus 1. Then subtract 1 from your power. So at the end of the day, I have the y, the x is equals to minus 1 plus this gives you minus x. Then your power minus 1 gives us minus 2. This is your answer. But you are not going to leave your answer this way. You must take note of what I'm saying right now. The concept of calculus, especially differentiation, whatever format in which your question came, is the format you are going to leave your answer. So then looking at this is the format in which our question came. And we say that y is equal to 1 over x. 1 over x is a fraction. We have numerator, denominator. So here we are going to transpose this to fraction. And once you have successfully done that, then we are good to go. Now, I have the y, the x is equal to minus x raised power minus 2, sorry, minus x raised power negative 2. This is our negative 2. We must understand the concept of minus 2 and negative 2. So in as much as this is standing on its own and it is negative, it becomes negative 2. And if it is 3, negative 3. But if it is attached to a number, a quantity, any letter at all, that is where the concept of minus will come in. Let's assume you are having this. This is where you can call this minus 2 plus 3. Another way to this is to say 3 minus 2. But if it is standing on its own, it becomes negative. That is that right way. Now, back to what I was teaching. So we have minus x raised to power negative 2. So for our indices, this one is same thing as minus 1 times x raised to power negative 2. So we have the y, the x is equal to minus 1 times, from our knowledge of indices, transposing this, from our knowledge of indices, transposing this is x raised to power minus 2. This one is as good as saying 1 over x raised to power. So this negative is 1 over, negative is 1 over, we are left with x2, this is x2. So at the end of the day, our the y, the s becomes minus 1 times 1. You can make this one look like a fraction as well, so as not to confuse you. This is minus 1 over 1, which is still minus 1. So minus 1 times 1 will give us minus 1. All over 1 times s squared is s squared. It's still the same answer. That is that by the way. Okay. I draw the curtain in under differentiation for first principle. So I move on to product rule. The product rule I wanted to teach before. So I saw the need to first and foremostly teach this before teaching product rule. Yes. In mathematics, you must learn step and stepping. Yeah, one leads to the other. You don't jump one step for another. You must do well and be a good mathematics student. You must understand this concept and obey it adequately. Okay, product rule. See, my handwriting is coming back now. It's been long like that. Product rule. So earlier on, I said product has to do with multiplication. Product is got when two or more numbers are multiplied together. Say a times a is a product of a squared. 20 times 20 is a product of 400. 7 times 7 is a product of 49. 10 times 10 is a product of 100. A times B is a product of AB. A squared times A squared is a product of A raised to the power 4, and so on and so forth. So here I'll say there's no point giving Roman figure I. Let me just go straight. Y is equals to UV. This is a foundation of product rule. UV here is a product, which is a product of U times V. UV means U times V. U times V will give us UV. So if that principle holds, which is illustrating what we're talking about, we say Y is equals to UV. So to illustrate this, I'm going to still use the concept of differentiation for first principle. And that was why I needed to teach that before teaching this. Yes, so that it will not look as if I'm rooting something from the sky. And somebody may ask me, where is this one coming from? Okay. Now, for every y, there's corresponding change in y. So we have y plus change in y is equals to u. For every u, there's no change in u. I have u plus change in u. Then for every v, there's change in v. So this is what I'm gonna have. So at the end of the day, I have y plus change in y giving me u times v will give me uv. U times change in v will give me u change in v. This is gone. So I move to the next one. Change in u times v will give me v change in u. Change in u times change in v will give me change in u, change in v. Because you should not have two different changes at the same time. So at this point in time, I'm going to transfer my y to this side. So I'll be left with change in y. So I have change in y equals to uv plus u change in v plus, I'm repeating everything there, v change in u plus change in u change in v. Then my y coming here becomes minus y. So at the end of the day, I'm having change in y is equals uv plus u change in v plus v change in u plus change in u change in v minus y. What is my y? UV. So you find out that this is my UV positive, this is my UV negative, this one cancel out this. I'm left with change in y giving me u change in v plus v change in u plus change in u change in v. So at this point, we divide through by changing s. So I have change in y equals u change in v plus v change in u plus change in u change in v. So we are finding everything and changing s. Changing s. Changing s. Changing x, changing x, changing x, changing x. You say, having gotten to this point, the next thing is to take limits. Taking limit. Taking limit, we have, we say change your y, change your y, we are changing s, equals to y, x. So our limit, we are changing x, change in 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 x our change in V tends to the V change in U tends to the U. You don't have two changes at the same time. Product of two changes. You have change in U, change in V, giving us zero. So having established this fact, I now have that change in y over change in x, which has turned to the y, the x, the y, the x is equal to u change in v over change in x, which has now become u dv over dx. Yeah, I need to replace the point. Change in x and turned to x. So here we have plus v change in u, which has turned to du over dx. The whole of this now has become 0. So from here we now say the y dx is equals to u dv over dx plus v du over dx. This is the formula for product rule. That is the formula for product rule. That is what I just derived. Formula for product rule. So I cite examples. Example 1. You have something of this nature. Y is equal to, let's say, 3x plus 2 into 4x plus 3. You are asked to solve this. It's very simple. This alone has given you a clue of what the equation is. What is this? These are two factors, product of two factors. This into bracket, this into this. I used to say this times this. So by that concept, you should know that I'm referring to what product rule. As you can see, UV meaning U times V. So this one is multiplying this as product rule. So applying that, it becomes obvious. Solution to this, it becomes obvious that this is our U, this is our V. So by virtue of that, I will now say let U be equal to 3x plus 2. So I'm going to differentiate U with respect to x. That will give me the U dx. So in differentiating this now, this one will give you the power here. This s has a power which is an invisible power 1. So by what I've already done, this one comes down and become 1 and 3s plus 1. This one plus 2. In differentiation, 2 does not have x. It's standing on its own, it's a constant. We say when we differentiate constant, it is 0. In differentiation, constant is 0. There is no point writing 2. This one is as good as saying 0. But I still want to show us why constant is always 0 in differentiation. Why we say constant is 0 in differentiation. Wow. This is 2. This 2 now, for a layman, all he can see here is just 2. Nothing more, nothing less. But a mathematician will look at this and say, all you see is not all there is. There is to say there is more to this. These 2 alone can equally mean 2x raised to power 0. Yes. So from the concept of indices, we say anything raised to power 0 is equal to 1. So 2x. This 2 is simple as 2x raised to power 0. So 2x raised to power 0 is simple as 2 times x raised to power 0, which will be 2x raised to power 0. And so from the concept of indices, anything raised to power 0 is 1. So this one is as good as saying 2 times 1, which is still saying 2. That is that by the way. So if this principle holds here, so 2 is the same thing as 2s raised to power 0. So if you now differentiate this, we say 2 is equal to 2s raised to power 0. So if you have to differentiate this from what I've already taught, our power comes down, becomes 0, times everything here, which is what? 2s raised to power 0. They will subtract 1 from our power. So having done this, we discover that 0 is multiplying everything here, and so when we multiply 0 by anything, the answer is 0. By anything, we like multiply 0 by 1,000,000, a trillion, the answer is 0. So that is why we say when we differentiate constants, the answer is 0. So now this one is as good as saying plus 0. So at the end of the day, du the x gives us 1 times 3 is 3 x x raised to power 1 minus 1. 1 minus 1 is 0. So at the end of the day, this one is saying as saying 3 times x raised to power 0, which is saying as 3 times anything raised to power 0 is 1. So this is just 3. Now that is for you. We move on to v. We say let v equal to 4x plus 3. So at the end of the day, we differentiate v with respect to s. That will be what will be the s, which is equal to, for me not to waste my time here, 4x plus 3. Answer is 4. If you go by what we did here. Okay, some people may still find it difficult. So this is 4x. This 4x means 4x plus 1. So we bring that in power, which is 1 times 4x plus 1. So plus in power. That is for this. We move on to this. We say when we differentiate constant, so it's not having x, just like this one is not having x. So when we differentiate constant, it's 0. So at the end of the day, we have the v, the x gives us 1 times 4x will give us 4x. So 1 minus 1 is 0. At the end of the day, this is 4 times x raised to 0, which is 4 times x raised to 0, which raised to 0 is 1. So having done all this, you'll be able to get your terms, your parameters called du dx and then dv dx. So we now recall our formula. Recall that dy, of course, in differentiation, what we will clear after is dy dx. This is what we are looking for dy dx. Dy dx is equal to our formula u. Oh, u dv over the s. This is u dv dx plus v du dx. It's better written this way. I put it this way. Yeah. Okay, u dv dx plus v du dx. So from here, our dy dx is equals to u. What is our u? Our u is 3x plus 2. Then times dv dx. Our dv dx, dv dx, dv dx is equals to 4. Mr. Bayo,
Well done.
let's go.
Thanks, Jerry. Please let me to give these things to Mr. Cooks.
Okay.
Alright. So when it comes back.
So from here we have v. Our v is from here, we have the y, the x, this us. The y, the x, this is the y, the x. This is looking like u, the y, the x. Is equals to 4 times 3x will give us 12x. 12x. 4 times 2 will give us 8. We are done with this. So we move on to this. 3 times the whole of this. 3 times 4x will give us 12x. 3 times 3 will give us 9. So having established this fact, it becomes so obvious that the y, the x is equal to 12x plus 12x gives us 24x. 9 plus 8 gives us 17. Your answer. Now, some people or some students may not be so intelligent to remember this formula in the exam hall or during test. So what I do to avert their exam predicament or test predicament is to give them shortcuts. Shortcuts. This is what I call shortcuts. If you cannot remember your formula, you should be able to remember shortcuts. So this is the equation before you. You want to apply shortcut now. 1 is equals to 3x plus 2. Then into 4x. 4x plus 3. If this is what you have here, I can't remember the formula, there is still hope for you. Of course, Bible said that there is a hope for you tree. If it is cut down, it will spring forth again. So if you believe there is still hope for you, there is hope for you. Alright. So this is what we have here. Of course, this is product. So I can say 1 is equal to, let me expand the brackets, open up the brackets. 3x times 3x. 3x times 4x, sorry. 3x times 4x gives us 12x squared. 3x times 3 gives me 9x. I'm done with this. So I move to the next one. 2 times 4x, we are using this to multiply this one after the other. 2 times 4x gives me 8x. 2 times 3 gives me 6. So at the end of the day, I'm going to have y is equal to 12x squared. 9x plus 8x gives me 17x. Then plus 6. So I haven't multiply out, you just go on to differentiate using your general formula. So I'm going to differentiate y with respect to x. That will give me the y, the x is equals. So I bring out my power. It becomes 2 times 12x raised power 2 is 2. That is for this. We move on to the next one. Plus, this is 17x. This 17x means 17x raised to power 1. So bring down your power, which is 1. Use it to multiply everything. You have 17x raised to power 1. Then subtract 1, just as you did here. Subtract 1 from your power. Then we move to the next one. Plus, this is 6. It doesn't have x, that is constant. We say we differentiate constant 0. So this one is 0. At the end of the day, you have the y, the x is equals to this times this gives us, this times this gives us 24x. 2 minus 1 is 1. To like put the 1 and leave it. It's the same thing. So we move to the next one. Plus 1 times 17x gives us 17x. So 1 minus 1 is 0. So at the end of the day, this is the y, the x is equal to 24x. 24x. I've told us countless number of times that anything raised to power 0 is 1. So this x raised to power 0, x raised to power 0 is same thing as 1. So 1 times 17 is 17. That is the same answer as this. So from here, we draw a curtain until we meet another time where I can talk about chain rule, composite function, um, quotient rule, and from quotient rule we can now talk about trigonometry, differentiation of trigonometry. Yeah. So from there, um, draw the curtain. Yes, draw the curtain for your level here. Then when you guys get to higher level, you can now talk about advanced calculus. Advanced calculus, where you will be talking about, you know, talk about um, sorry, please pause it